Hello and welcome to my YouTube channel. This is Gurunatha and today in this video we are going to learn SQL Database Normalization. Yes friends, with the design mistakes. Yes, you heard right. We will do a design mistake and we will rectify it by applying normalization rules. That is, first normal form, second normal form, third normal form, Boyce Codd normal form and fourth normal form rules. As a fresher or a DB expert or a developer, when it comes to working on the database structure like creation of tables, then it must that we should follow the normalization rules, especially when our database is more of OLTP processing, that is online transaction processing. Like here we expect that insert, update, delete will happen more frequently, especially working on extraction of raw data or while working on some bank database or some live website for taking the customer details and so on. Remember friends, if you follow a database normalization rules, then automatically you can prevent a database from inconsistency, dependency, duplication of data, repeating group problem, bad data, and at the same time you can improve your data quality, your data integrity. So I request that please watch this video completely and learn how to apply the database normalization rules step by step. If you are new to this channel, then please subscribe to our channel and give us a big thumbs up, because your one like and one subscribe really motivate us to create more such technical videos on SQL Server. So friends, without wasting any time further, let's get started with today's video. So let's start with the first normal form rules. So let's see what does the first normal form rule says. So it says that every table must have a primary key. Every table column must have atomic value. Every table should not have any repeating groups. Every table should not have any duplicate rows. No duplicate rows. So this is what the rules of first normal form says. So now with the design mistakes, let's understand the first normal form. So for that, let me just go and connect to my server here, and let's go to the databases, that is test Sunday databases, and here I'm going to create a table called table patient. So let me create a columns here, patient ID. So I will say nvarchar patient name, nvarchar patient SSN number, so nvarchar, and patient problems. So this I'm going to name it as TBL patient. So there you go. Now let me just refresh it and let's enter some data over here. So I will say 1001 Arjun, some SSN number, problem, cold. 1002 Sham, some SSN number, having cough. Okay, and now again I'm going to enter 1001 Arjun with some SSN number, having cold, or I will say fever. So friends, as you can see that we have a duplicate row here, that is 1001, that is Arjun. So it is quite possible that this patient and this patient belongs to the same person name, and it is also quite possible that this patient name is different and this patient name is different. So when a table does not have a primary key, or I will say unique keys, then it becomes very difficult to identify the records, whether they are duplicate records or whether they are genuine records. So it becomes very difficult. So when it comes to the big million records, then it becomes more difficult when your table structure will not have any primary key or unique key. And you can see that I can able to enter the duplicate rows without any problems. So I have purposely entered these duplicate rows just to showcase you that a table which does not have a primary key column or a unique key column, there we can have lots of duplicate rows here, like I have here right now. Okay, so you can see that I have a two columns here, that is patient ID and patient SSN number. Both looks like a candidate keys, and you know that among the candidate keys only we have to select the primary key. Here I am going to choose the patient ID as my primary key column. Why not this patient SSN number? Is just because this numbers is been provided by the government authorities. Whether you can say this as patient SSN number or patient Aadhaar card number, these numbers are provided by the government authorities. And if you see that when it comes to the patient ID, on this column I will get a chance to set this column as an identity column with the auto incremented value. So it means every time when the new row is been added here, automatically a new unique number will be generated here. So that is the flexibility which I will get when I will choose the patient ID as my primary key. So this is the reason I am going to make this column as a primary key. So let's do that. So for that, first we need to make this patient ID as integer. You can also have patient SSN number as a unique key also. So it will give you more filtration when it comes to querying a table, right? So for now I'm going to make this patient ID as a primary key. So I will say set as primary key, and I will make the identity as yes with the identity seed, that is 1001. Yes, we cannot create the primary key just because we have some duplicate rows. So let's remove that. Done. There you go. You can see that I have successfully added a primary key to my table. Now let's see what happens. Now here you can see that it is not giving me an option to enter any value here, and when I type a data here called Arjun, you can see that it has automatically created a new unique number, that is 1003, means it is auto incremented the number automatically. So this gives me a flexibility, or I can say this gives me a chance to identify the record whether this Arjun is the same patient name or this Arjun and this Arjun is belongs to the different person name. And as per the design, now we can say that this Arjun patient name is different and this Arjun patient name is different because their patient ID number is different here. So this is what the benefit of having a primary key in the table. Now and let's go and understand the second problem of first normal form, that is atomic value. And you can see that we have a patient table here, right? And inside that we have the patient name here. So it is quite possible that a patient Arjun can have a multiple problems. Like for example, he can have cough, he can have cold, he can have fever. So generally how the DBA expert will do the mistake here. So when we have a requirement saying that a patient can have a multiple problem, so generally instead of creating a new column, what he will do, he will just enter the multiple values with the separator pipe, and he will say a fever and he will say cough. So this is it. So he will say that I have find the solution by entering the multiple values in a particular column only. So that is a patient Arjun is having cough, cold, fever. That's it. So now as per the rules, it is one of the biggest design mistakes. So what does the first normal form rule says that every table should have a atomic value, that is the single value should have. So we cannot have multiple values like this with a separator of comma or with a separator of semicolon or with a separator of pipe. Okay, so this is completely wrong. So now database expert, or I will say database design expert, will say that okay, I need to enter multiple values at the same time. I need to maintain the atomic value also. So yes, I can do that by creating more columns on the same table. So what he will do the design mistakes, let's see that. So first he will rectify this to cold, that's it, and he will go to the design here and he will name this as problem 1, and he will create new column here called problem 2, again one more column problem 3, and this will be like n varchar 50. Save. Now let's check that what happens with this design change. So there you go, the Arjun is having a problem 1 called cold, and he is also having fever and cough. So there you go, means we have satisfied the patient Arjun here. What about patient Sham and patient Raju? You can see that we have some redundant columns here. For problem 1 cough it is there, so it is satisfied for Sham, and for patient Raju problem 1 fever is there, so it is also satisfied for Raju also. But what about the two more null columns for Sham and Raju? You can see that here. So it means we have some biggest design mistakes here, that is we have some redundant columns here for Sham and Raju, right? So what does the first normal form rule says, that we should not have any repeating groups. For example, like this, problem 1, problem 2, problem 3, these are known as repeating groups. So every table should not have any repeating groups, every table should not have any redundant columns. So how to get rid of this problem then? So to satisfy the atomic value, we have created the more redundant columns, especially for the record Sham and Raju. So how to fix this problem now? So to fix this problem, we need to split the table into the multiple table. That's what the normalization means. In a single line, if you want to understand normalization, then splitting up the table into the multiple logical tables are known as normalization. So yes, we are going to split this big table into the multiple logical tables. So to do that, I am going to create a new table here called problem table, that is with the problem ID, problem name. So this I will name it as TBL problem. So there you go, every table must have primary key and also the identity. Yes, save, that's it, refresh it. Now let's enter some data over here, and here I will say cold, cough, fever. That's it, we are done. Now what I will do, first thing over here, I will go to the design and I am going to delete all the design here. I mean all the columns. Yes, I'll say save. That's it, we are done now. So now what I am going to do, I am going to add a foreign key here, that is foreign key for problem ID, that is problem ID underscore fk. Fk denotes as a foreign key, so I will say int. Yes, so there you go. Now let's go and edit the data. So you can see that we have a problem 1, we have problem 2, and we have problem 3. Let's add the problem for the patient. I will say 1 for Arjun, again 1 for Sham, and 3 for Raju. So it means we have added cold for Arjun and Sham, and fever for Raju here. And if you see our table design structure, still there is no scope for adding the multiple problems here. So as we have spoken already that one patient can have multiple problems. That is, Arjun can have fever also, Arjun can have cold also, but you can see that with this structure also we don't get the scope of adding the multiple problems. As you can see that to maintain the atomic value in a column, what we did, we have added the multiple problem columns, and because of that a repeating group problem has been created. To solve that repeating group problem and the redundant data problem, what we did, we splitted the table into the multiple table, right? But if you see a real-time scenario here, one patient is having multiple problems here or one or more problems, and at the same time a problem can have multiple patients also. So it means we have a scenario where we can have many to many relationships kind of a thing. Means one patient can have multiple problems. Similarly, one problem can have multiple patients also. So for the same, we need to create one more table for many to many relationships. So for that, what I will do, I am going to create one more table here called table treatment. So this will be like treatment ID integer. So this will be like patient name, patient ID underscore FK, and we have problem ID underscore FK. This will be like integer. There you go. Let's save this table as TBL treatment. And let's make this column as primary key. Now let's also make this both columns as foreign key. So first what I will do, I will go to the TBL patient design, and here I'm going to delete the problem ID FK. So there you go, save. And now from here I'm going to add the relationships. So to add the relationships, just say add, and here specify the columns. So my primary key table is TBL patient. From here the patient ID is the primary key, and in the foreign key table of TBL treatment, my patient ID FK I'm going to select here. I will say OK. At the same time, let's add one more foreign key relationships. So for TBL problem, so this will be like problem ID. From here problem ID FK. So there you go, close, save. So there you go. Let's refresh the table and let's edit the data. So I will say, so first let's do the auto increment also for primary key treatment ID. So let's set this identity to yes, and I will say save. There you go. Now let's edit the data. So for patient ID 1001, let's add a problem ID, that is 1. For patient ID 1001, let's add one more problem 2. For patient ID 1002, let's add a problem 1. For patient ID 1003, let's add a problem 2. 1003 again, let's add a problem 3. There you go. So it is done. As you can see that, yes. Now to check the output, here we need to write the inner join query. So let's write that. So friends, as you can see that we have successfully written an inner join query here for the 3 tables, that is table patient, table problem and table treatment. And when we ran this query here, we got the following output, and it is clearly given us a proper output for one patient with the multiple problems. As you can see here, a patient Arjun with the patient ID 1001 having the multiple problems like cold and cough. Even 1003 Raju is also having the multiple problems cough and fever. So it means by splitting up the tables into the logical unit tables, we have successfully got the output how we want it. At the same time, we maintain the normalization rules also. So as I told you, normalization is all about splitting up the table into the logical unit and combining, or I will say joining all the tables together by using the SQL join. So you can use either inner join, you can use either left join, right join, or full outer join. So it means we have successfully satisfied the rules of first normal form. That is, every table is having the primary key, every table is having the atomic value, there is no repeating group problem, there is no duplicate rows. So it means we have successfully climbed the first normal form ladder, right? Now let's go and talk about the second normal form. So here I am going to write second normal form. So in the second normal form, what it says that you need to satisfy the first normal form. Then after that you need to remove the partial dependency, right? So in the second normal form, what we need to achieve is we need to first achieve the first normal form, and that we have achieved already. Now second, we need to remove the partial dependency. So let's do that with the design mistakes. So first we will create a design mistake and then we will try to remove the partial dependency. So once we remove this partial dependency, it means that we have successfully achieved the second normal form also. So let's do that. So you can see here I have created one more column here called doctor ID as a primary key in my table problem. Okay. So you can see that the table problem has been modified here so that we can create a design mistake here, and you can see that we have added a doctor ID here. Means we have doctor name and doctor SSN number also here, right? So you can see that for one problem we have one doctor here. So let's go and add the data first. So let me cancel this, edit the rows. So I will say doctor ID 2001, problem name cold, doctor name Alvin, doctor SSN number some number. So let's add the problem ID also, 2002. I will say cough, Robin with some SSN number. There you go. Now you can see here we have one doctor for one problem here, right? So this is also one of our design mistakes here, and you can see that we have two primary keys here like a composite keys. Okay, and you can see here clearly that on doctor ID, doctor name and doctor SSN number is dependent. On problem ID, problem name is dependent. Means you can see that there is no relationship between a doctor and a problem. It is very much possible as per the real world scenario that one doctor can solve the multiple problems. At the same time, for one problem we can have multiple doctors also. For example, I can have one more doctor here for cold, let's say Bhavik with some SSN number, right? You can see that. So for one problem we can have multiple doctors also like we have here and at the same time one doctor can solve multiple problems also. So it is very much possible, and you can see that the columns which are present in the table problem are partially dependent on doctor ID, and this problem name column is partially dependent on problem ID. Means this doctor is not depending on this problem. doctor is dependent on the doctor ID. This is what the functional dependency is here. Means these non-prime key attributes, that is doctor name and doctor SSN number, are partially dependent on doctor ID, and the problem name is partially dependent on problem ID, right? So here we need to remove the partial dependency problem here, right? So how to remove a partial dependency here? It's so simple. We have to split up the data. It means we need to split up the tables basically. Okay, so for that, let's split up the table here. So let me create a one more table here called table doctor. So I will say doctor ID integer, doctor name, and varchar, then doctor SSN number. Let's make this as a primary key. Let's set up the identity here. So I will say identity yes. There you go. Let's save it with the name table doctor. So there you go. Now what we will do, we will go to the table problem, and here we are going to remove the column doctor ID, doctor name, and doctor SSN number. Let's set this as primary key again, and let me save this, and let's set the identity also here. There you go, we are done. Now let's enter the values here in the table problem and as well as in the table doctor. So let's say edit. So there you go. Let's do the doctor entry here. Edit. So here it will be Dr. Alvin with some SSN number, Dr. Bhavik with some SSN number, then we have Dr. Robin with some SSN number. So there you go. Now how to combine these doctors with a patient here? So it's so simple friends. We just need to go to the TBL treatment, and here we need to change the design, and here we need to add one more column, that is doctor ID FK. Means for every patient we have a doctor here, right? I'll say save, and let's do the data entry here. So I'll say edit. So for patient ID 1001 we have problem ID 1, doctor 1. For patient ID 1002 we have problem 2, we have doctor 2. For patient ID 1001 again we have problem 2 and doctor 3, or I will say doctor 1 only. So for patient 1003 we have a problem 1 and the doctor 3. Again we have 1003 patient with problem 3 and doctor ID 3, or I will say doctor ID 1. Okay, so there you go. Now to see the output, let's write the inner join query now. So let's do that. So there you go, we have written a nested inner join query here. As you can see that we have combined the TBL treatment with the TBL patient, with the TBL problem and the TBL doctor. And when we ran this query, you can see the output here. That is a patient named Arjun having the problem cold, and treating doctor is Dr. Alvin. And the same Arjun having the cough here, and the same doctor is treating here. And you can see that for Raju, who is having the cold here, the treating doctor is Robin and the treating doctor is Alvin. And for Sham, for cough, a treating doctor is Bhavik. So you can see that we have successfully removed the partial dependency, and at the same time we already achieved the first normal form also. So it means we have successfully achieved the second normal form. Now it's time to go and achieve the third normal form. So let's see that what the third normal form says. So it says that we need to satisfy the second normal form. Definitely, when I say second normal form, indirectly first normal form also. Then after that, we need to remove the transitive dependency. Right? So what is transitive dependency? Let's understand that with a design problem. So let's do that. So as you can see that this is our table doctor here. Okay, and in the doctor table we have added a design problem here. That is, we have added the country column and we also added the city column. Means Dr. Alvin living in Mumbai, Dr. Bhavik living in Old Trafford, that is in UK, and Dr. Robin living in US Dallas. And you can see that this country name is dependent on the doctor ID, or I will say a doctor name basically. So where the Alvin is living in India, Bhavik is living in US and UK and so on. And if you see that this city is dependent on the country here. So when the country changes, this city will also change, right? But a country will change only if the doctor will change here. So it means this city is dependent on this country and the country is dependent on this doctor, and indirectly the city is dependent on this doctor ID. So it means we have a column A, we have a column B, we have a column C here. So B is dependent on A, C is dependent on B. It means C is indirectly dependent on A here. So this is what a transitive dependency means. So this dependency we need to remove if we want to achieve the third normal form. So how to achieve that? Let's understand it. So let's go to our SQL Management Studio. So first what I'm going to do here, first I'm going to remove this country and city here from this table. There you go. And here I'm going to add a city ID underscore FK integer. There you go. I'll save this first. Then I'm going to create two more new tables, one for country and one for city here. So here I will say country ID integer, country name, and varchar. So I will set this as a primary key and also the identity. So there you go. I will call this table as TBL country. Now I am going to create one more table for city here. So I will say new table. I will say city ID integer, city name, then we have country ID underscore FK integer. Let me set this as a primary key, also the identity. I will call this table as TBL city. There you go. Let's do the data entry here first. Let me refresh the tables here. So let me say edit. So we have a country India, UK, USA. There you go. Let's add the city also. Mumbai, country ID 1. I will say Old Trafford. I will say 2. Then we have Dallas 3. There you go. Now we will go to the TBL doctor, and here we are going to enter the city ID as 1, 2, 3 here. So there you go. Now to see the output, we need to write the inner join query here. So let's do that. So here you can see, friends, I have written a nested inner join here, and here I have connected a TBL treatment. You can see that I have connected the TBL patient, I have connected the TBL problem, TBL doctor, TBL city, TBL country here, right? So when I run this query, you can see the following output here, that is a patient Arjun and the treating doctor is Alvin, and the patient is having the problem cold, and the doctor is living in country India and the city Mumbai, and the patient Sham having the problem cough, treating doctor is Dr. Bhavik, who is living in Old Trafford, UK. Then we have our Dr. Robin here, whose patient is Raju, having the problem cold, living in Dallas, USA. Means Dr. Robin living in Dallas, USA. So friends, as you can see that we have successfully removed the transitive dependency, and we already achieved the second normal form also. So it means we have successfully achieved the third normal form. Now let's go and understand, that is BCNF, that is Boyce Codd normal form, BCNF. So let's understand that. In order our table to be in a BCNF, then we need to satisfy the two conditions here. That is, the first one is our table should be in a third normal form. Yes. So third normal form. Second, we need to remove the dependency of non-key column deriving the key columns, or I will say non-prime attributes deriving the prime attribute. So we need to remove that dependency. So here I will say remove the dependency of non-prime attribute deriving the prime attribute. So this dependency we need to remove. Okay, so this is our second criteria, our table to be in a BCNF, then definitely we need to remove this dependency. So in any condition we want that our key column should derive non-key columns. If you see in our second normal form, that is a partial dependency, all the non-key columns dependent on the partial key columns, right? So if you see that there our doctor columns were dependent on the doctor ID and the problem columns were dependent on the problem ID. And in the third normal form, that is the transitive dependency, there also non-key columns dependent on the non-key column only, that is the state column dependent on the country, that is C to B, and then we have the B to A. So that dependency also we have removed in the transitive dependency to achieve the third normal form. Now in BCNF, here we need to remove the non-prime attribute deriving the prime attribute dependency. So let's create a design mistake and let's understand more here. So if you see here, friends, I have already created a new table called problem 2. You can see that, and here I have a patient ID, and here I have a problem name, and here I have a doctor column here. Okay, so you can see that a patient ID 1001 with a problem code, and then we have a doctor here. Then for the patient 1003, same problem, we have a different doctor here. So it is very much possible that for one problem we can have multiple doctors also, like we have for one problem, like how we have a specialist doctors in the real world scenario, the same way here also we have for one problem we can have multiple doctors. Then for cough we have different doctors, for fever we have a different doctor here. Okay, so it means If I want to find out a doctor name here in this table, then I can use the patient ID with the combination of problem name here. So let me just show you that with the query. So you can see that here I have written a query here where I am displaying the patient name, problem name, doctor name from the problem2 table. I have inner join with the table patient, right? You can see that. And here you can see that here I am using in the where condition patient ID with the problem name. And when I ran this query, you can see that I am getting the doctor name here. So if I make this as cough, or let's say if I make this as cold only, cold, and here if I say 1001, see, you can see that same problem with a different doctor name. And this means that this patient ID and this problem name are acting like a candidate keys to find out the doctor name here. So in this table, this both columns are acting like a candidate keys, right? Candidate keys means definitely prime attribute columns. So now let's understand in a reverse order now. So for example, if you want to understand the doctor specialization, means a Dr. Alvin is specialized for which problem, then yes, you can find out by using the doctor name. For example, Dr. Alvin is a specialized doctor for cold, Dr. Robin is specialized doctor for fever, Dr. Bhavik is specialized doctor for cold. You can see that I can use the doctor name to get the specialization of a problem name. So for example, let me just show you here a query. You can see that I have written the same query, but in the where clause, as you can see here, I have used the doctor name here. As you can see that Dr. Robin, and if I run this query, you can see that I am getting this output. That is, I am getting the problem name here, means I am getting the specialization of the doctor name here. And if I change it to Alvin here, you can see that Alvin, and if I run this, see, I am getting the problem name here, means Dr. Alvin is specialized for cold problems. And if I make this as Bhavik, so if I run this, you can see that the problem name cold appeared here. Okay, and if you see here, it means that doctor name, a column which is non-prime attribute column, is deriving the prime attribute column problem name, because in this table patient ID and problem name are acting like a candidate key here, and a non-prime key column doctor name is able to derive the problem name, which is a prime attribute column in this case. So this type of dependency we have to remove here in order our table to be in a BCNF. We have to remove this type of dependency. So how to remove that dependency? It's very simple, friends. Just split this table into the multiple logical unit table. For example, you can remove the problem name and create a separate table called problem. As you can see, we have created here, that is table problem. You can also remove the doctor name from here, and you can create a separate table for doctor. You can see that here we have already created with the columns. You can see that with the problems also, you can see that, right? So like that you have to create the separate tables, and for this type of centralized table you can create one table for many to many relationships like we have here, that is TBL treatment. Can you see that? We have a patient ID, we have a problem ID, we have a doctor ID. That's it. So once you have this type of structure in your database, then you can easily run this program. You can see that if I run this query here, you can find out, you can get the problem name, you can get the doctor name, you can get the country name, you can get the city name with the patient name also. So it means we have removed the non-prime attribute deriving the prime attribute dependency from our table. So it means that we have satisfied the third normal form and we have also satisfied the BCNF also, which is nothing but the upgraded version of third normal form. Now let's go further and talk about fourth normal form. If you want a table to be in a fourth normal form, then you must satisfy the two conditions. That is, the first condition is that your table should achieve the BCNF. That is the first criteria. Then your table should not have any kind of multi-value dependency. So we have to remove the multi-value dependency to achieve the fourth normal form. So here I will say remove multi-valued dependency. So yes, we have achieved our BCNF and now we need to remove the multi-value dependency. First, let's go and understand what is multi-value dependency. Then with a design mistake, we will remove the multi-value dependency. So for that, let me just go to my table here. If a table to be in a multi-value dependency, then it should have three criteria. So let's see that. Let me open up my Paint here. You can see that we have a patient, we have a problem, and we have a patient hobbies. Let's consider this as A, B, and C. So what is multi-value dependency here? Let me explain you that. For every single value of A, there should be multi-valued B. Means for every single value of A, we should have multiple values of B. So this is our first criteria. Okay, so I will say first. So what is the second criteria? Second criteria says that in a table at least minimum 3 columns should be there. So 3 columns. So this is the second criteria. So in a table we should have 3 columns. That is our second criteria. So what about the third criteria? Third criteria says that there should not be any relationship between column B and column C. Okay. So you can see that we have a table here. You can see that a column patient ID, a problem name, and patient hobby. And you can see that for every single value, that is patient ID 1001, we have 2 problems here. And you can also see that there is no relationship between problem name and patient hobby. Yes, you can see that this is the patient hobby. And for every problem, we have a hobby here. You can see that for cold we have a hobby here, for cough we have a hobby here. And this is looks like a very bad design, because what happens, this will lead to generate 2 more rows here. So for example, we can have 2 more rows here stating that 1001 with cold, then we can have football also, and then again we have 1001 cough with the patient hobby as cricket. So this is what the multi-value dependency means. When you have multiple values for a single value here, and there should be a 3 columns. Yes, we have the 3 columns, and there should not be any relationship between the problem name and patient hobby, that is column number B and column C. So this is multi-value dependency which we need to remove so that we can achieve the fourth normal form. So how to do that? It's very simple, friends. Just go here and create new table called hobby. Hobby ID, hobby name, and varchar. Give this as primary key. Set this as identity yes. Save this as table hobby. That's it. Refresh it. and enter the hobbies here. So cricket, football, tennis, that's it. Now to assign with the patient here, you can go to the TBL treatment here, and here you can create one more column called hobby ID FK. So you can see that hobby ID underscore FK with the integer. That's it. Save it. Now you can open this and edit it. So here I will say 1. So here I will say 2. Here again I will say 2. This will be like 1. This will be like 2. There you go. We are done. Now let's execute the inner join query and let's see the output now. So here you can see that here I have written the inner join query. You can see that a table hobby here, that is joining with the table treatment. You can see that on ID, that is hobby ID FK, is equal to table hobby dot hobby ID, right? And here I have displayed the hobby name here. You can see that, right? So when I run this query, you can see that we can see the patient name here with the hobby also, right? With the problem, with the hobby, right? With the doctor name, with the country name, with the city name. So it means we have successfully removed the multi-value dependency from the table here. So it means that we have successfully achieved the fourth normal form also, because our table was already there in the BCNF, and now we have successfully removed the multi-value dependency. It means we have achieved the fourth normal form also. So friends, I hope that you liked this video. In case if you have any queries or any doubts, please post your doubts and queries in the below comment section of this video. And if you really like this video, please give us a big thumbs up, and in case if you are new to this channel, please subscribe to our channel, because your one like and one subscribe really motivate us to create more such technical videos on SQL Server and as well as on MSBI. So thank you very much friends. Have a nice day.